Okay, well, good morning, everyone. I want to get started here on an event this morning on how do we deal with deep decarbonization, although as we were talking about it yesterday, we realized it's deep and deeper. It's all deep decarbonization. It's all hard. Hard and harder, I guess, is the way to put it. Anyway, I'm Rob Atkinson. I lead ITIF. We have a great panel this morning. We're rolling out two new reports today at ITIF. One from Colin Cunliffe on really looking at how do we decarbonize a whole set of problematic sectors that, frankly, are not on the path to decarbonization with current technologies and current R&D portfolios in a serious way. And then David Hart, who leads ITIF's clean energy innovation work, is going to be doing a deeper dive onto long-term storage. So this morning on the way from the metro to our offices, I encountered another technology where I really think we need deep decarbonization, Colin, and I think we should put it in the addendum to the paper, and that's leaf blowers. Because not only is this thing spewing gas on the street, fumes, but it's incredibly loud. I'm like, why can't you have a battery-operated leaf blower? And I assume it's because the battery density, you don't want to carry this heavy battery, and gas is better. So better batteries, we need an ARPA-E program, call it Leaf Beast or something, I don't know. But I do, all seriousness, I think this is such an important issue because when we look now at the recent report from the White House, the Democrats obviously are in control of the House. Republicans, after the loss in many suburban districts, I think that our prediction is there's going to be somewhat of a new consensus on climate, that it's real and we got to do something. And I think when we think about that, both sides really haven't fully grasped and come to grips with what we have to do. There's a lot of wishful thinking among the left, if you will, that if we all just sort of, forced companies to do things and had a little bit more tax incentives for solar, and if you just took the bus a little bit more, that, it'll all work out. Not when the global population is going to grow by 30 or 40% and per capita incomes are going to go up around the world. That's just not going to be enough. You need radical and deep decarbonization. And many on the right argue with some legitimacy that if we sort of go too fast and too far with regulation, that we impose costs on consumers. They're not going to like that. All we have to do is look at France, where there are riots on the street over raising gas taxes, and they worry about competitiveness. And I think when you put that together, the grand bargain really is and should be technological innovation. It gets us deep decarbonization at minimal or actually negative cost, if we can do it in a way that's cheaper than fossil fuels. And it can boost competitiveness by spurring the growth of leading U.S. industries. So that's really what we're going to talk about today, and in particular, Colin's going to talk about an R&D agenda for how we would get there. So I'm going to introduce the panelists first, and then we'll just jump right in. Colin Cunliffe is a senior policy analyst at ITIF. He previously worked at DOE's Office of Energy Policy and Systems Analysis. He'd been a AAAS fellow in the Senate, and he has a PhD in physics from UC Davis. David Hart, who I don't have his bio, but I know David's bio inside and out. David is a longtime professor of public policy at George Mason University, had been up at the Kennedy School, and his main area of research focus now is clean energy, and he's also dual posts still at George Mason, but also head of our ITIF's Clean Energy Innovation Project. Judy Greenwald, I'm not going to do the long bios, by the way, they're on the website, is a principal of Greenwald Consulting, where she provides energy and environmental expert advice, strategic planning, and policy analysis. She's also a fellow at Princeton University's Andlinger Center for Energy and Environment, and until 2017, she was the Deputy Director for Climate, Environment, and Energy Efficiency in DOE's Office of Energy Policy and Systems Analysis. And last is Bob Percepsi, who's the president. Pardon? Percepsi. Sorry, Bob.
All right.
Percepsi.
Never happened.
I know, I was thinking about that. I saw that and I said, I'm going to mess the name up, and Bob's going to be not surprised. So, President of the Center for Energy and Climate Solutions, C2ES. He's been involved in environmental policy for a long, long time. Most recently as Deputy Administrator of the U.S. EPA from 2009 to 2014, and prior to that in his career he had also been the Secretary for the Environment of the state of Maryland. I would just also mention to folks who are watching online, if you want to follow along with the slides, just go to the website and you can click on that and you can actually see the slides on your browser. So with that, Colin.
Randolph.
Red has to be green.
Sorry. Oh, it has to be on. I think that works. There we go. Energy, right. So, good morning. Thank you all for being here. Today I'm going to present my report, Developing an Innovation Agenda for Deep Decarbonization and Bridging Gaps in the Federal Energy RD&D portfolio. And I also want to mention, if you're following along on Twitter or online, please use the hashtag ITIFEnergy. So this talk addresses three main points. First, that we need innovation to address climate change. Second, I identify the most challenging sectors to decarbonize, and then develop an innovation agenda to address these harder to decarbonize sectors. Now, ITI previously published a report in 2013 developing a logic chain to a global clean energy innovation policy. And I'll highlight some of the key elements. First is that climate change is a global problem and is already impacting society. And second, addressing climate change will require reducing carbon pollution to zero before the end of the century. In fact, the recent IPCC special report on warming of 2.7 degrees Fahrenheit finds that we need to reduce carbon pollution to zero by 2050. But the main point is clear: lower emissions is not enough. We need to be more aggressive, and we need to shoot for zero. This will require a broad set of clean energy technologies that cover all sectors. And then clean energy needs to be cheaper and better to realize widespread and global adoption. And then finally, developing these clean energy technologies requires smart innovation policy. It seems pretty straightforward, but this does contrast with some competing ideas that we already have all the technology we need, or that just a carbon tax is going to fix it all. We support a carbon tax, but we need radical innovation in clean technologies. And we can see that by looking at global projections of global carbon dioxide emissions. According to the International Energy Agency's reference technology scenario, global emissions are projected to continue to increase with current technologies. And what's notable about, this projection on the left is that this projection incorporates the Paris Climate Agreement and incorporates the country's climate targets. It also incorporates learning curves for clean energy technologies and anticipated future cost reductions for renewables and other clean energy. But despite this is not enough to account for growing expansion to energy services, and unabated fossil fuel consumption is projected to continue to increase. Now, on the right, I've got projections from the Department of Energy's Quadrennial Energy Review of domestic emissions under several different technology scenarios. This top blue line is emissions under a reference technology scenario, and it shows emissions leveling off basically through 2040 when we need them to continue to decrease. Similar to IEA's technology scenario, this incorporates, again, learning curves and future cost reductions for clean energy technologies. Now, of course, the Department of Energy already has an energy research and development portfolio, and the purpose is to improve the performance and reduce the cost of clean energy technologies. So it's a worthwhile question: what happens if DOE achieves all of its performance targets? This is the solid green line, and you see a modest emissions reductions. And then the Quadrennial Energy Review also conducted a further aggressive scenario contingent on doubling investment in energy research and development. Under this more aggressive scenario, emissions declined to 38% below 2005 levels by 2040. So there are two key takeaways. Clearly, DOE's energy research and development portfolio has the potential to bend the emissions curve down. Equally clearly, it's not enough, and there's a wide gap between an aggressive energy R&D portfolio and what is needed for deep decarbonization. So that begs the question. This gap points to a set of harder to decarbonize sectors and technologies that are either not well represented under DOE's current energy R&D portfolio, or that are funded at levels that are insufficient to address the challenge of decarbonizing these sectors. So this next session looks at identifying these difficult to eliminate sources of emissions. This is a graph from I think a June 2018 publication in the journal Science that identifies difficult to eliminate emissions in each sector. Within the electricity sector, highly reliable electricity. Within the transportation sector, aviation, shipping, and long-distance road transport that are challenging to electrify. And within the industrial sector, process emissions and emissions related to high-temperature heat. And here they use steel and cement as the two biggest industrial sectors. And in all, these account for about 9.2 billion metric tons of carbon dioxide globally per year. Now, I don't want to suggest that any of the rest of this is easy, so we're calling this hard and harder to decarbonize. So don't get the impression that buildings is easy to decarbonize. So I'm going to go through each of these. First, for electricity, emissions in the U.S. have already declined by 28% since 2005. Most of these emissions have been low-hanging fruit, as older, uneconomic coal-fired power plants have retired. That lost generation has been replaced by new natural gas plants and renewable energy. And if you're keeping score, the Energy Information Administration attributes 61% of these emissions reductions to natural gas and 39% to renewables. But there are limits to the emissions reductions that can be achieved just from more natural gas and renewables. And in particular, so natural gas, of course, is lower carbon, but not zero carbon. And there are limits based on technical feasibility as well as cost concerns for systems with high dependency on variable renewables. So what we need is zero carbon firm or highly reliable electricity that can be dispatched as needed to balance variations in both electricity demand as well as variations in variable output. The science study that I referenced estimates that about a third of electricity-related emissions are due to this highly reliable electricity, about 4 billion metric tons of carbon dioxide per year. Within the transportation sector, emissions in the U.S. have barely budged due to a lack of low-carbon alternatives. Electrification of light-duty vehicles has emerged as a predominant pathway to deep decarbonization, and electrification can, in tandem with decarbonization of electricity, achieve deep emissions reductions if the cost of batteries continue to fall. But batteries are unlikely to ever reach the energy density requirements for aviation, shipping, and long-distance transport, where things like payload capacity and cargo space are important factors. So you see on this graph the energy density of hydrocarbons in purple, and diesel, jet fuel, and gasoline are right at the top. Hydrogen at various pressures are in blue. Ammonia, not typically considered as a fuel, but it can be combusted for energy or used in a fuel cell. Ammonia is in red. And then you see in the bottom left-hand corner lithium-ion batteries that are orders of magnitude away from the energy density of petroleum-based fuels. About 2.2 billion metric tons a year come from these three sectors: aviation, shipping, and long-distance transport. And then within the industrial sector, both process emissions and high-temperature heat fall into this category of harder to electrify. So process emissions are emissions related to chemical transformations, such as the calcination of limestone to make cement, and they cannot be eliminated simply by switching to low-carbon energy. And high temperature heat is typically generated by on-site combustion of fossil fuels and is not easily electrified. So what we need are zero carbon sources of high temperature heat and also some way to abate these process emissions. The science paper estimated about 3 billion metric tons a year of harder to abate industrial sector emissions. This likely lowballs it because this only includes process emissions from steel and cement. It doesn't include process emissions from other sectors such as ammonia and petrochemicals, and it doesn't include much high temperature heat emissions. And then finally, the world may not reduce carbon pollution fast enough to avoid the worst impacts of climate change. The recent IPCC report, again, found that all pathways that limit warming to 1.5 degrees Celsius require atmospheric carbon dioxide removal on the scale of 100 to 1,000 billion metric tons of carbon dioxide between now and the end of the 21st century. So here, we need whole new technologies, including direct air capture, minimal carbonation, bioenergy with carbon capture and sequestration, a whole slew of technologies. So finally, we get to an innovation agenda for deep decarbonization, which we've oriented around 6 technology missions. 4 of these technology missions are intended to address these difficult to eliminate sectors. And many of these technologies address more than one harder to decarbonize sector. For example, advanced nuclear energy that operates flexibly can provide highly reliable electricity. It can also provide industrial heat for many industrial processes. Long-duration storage, coupled with variable renewables, can also provide highly reliable or firm low-carbon electricity. And I'm going to go through each of these 4 technology missions and some key recommendations around those. But also, carbon removal doesn't address any one harder to decarbonize sector. That's why it's in a different color. And then for all of these missions, we'll need fundamental breakthroughs in basic energy sciences and basic science research. So this report, as I said, develops these technology missions, develops more detailed recommendations. I'll refer you to the report for those. I'm going to highlight some of the key recommendations and just summarize them briefly. So first, for advanced nuclear energy, nuclear power currently provides 20% of U.S. electricity generation and a majority of zero-carbon electricity, more than wind, solar, hydropower combined. But the cost of new nuclear power plants are rising due to site-specific construction and design, and many existing plants that are not valued for the zero-carbon attribute of their electricity are at risk of premature retirement. So this has led to some researchers referring to nuclear power as the vanishing low-carbon wedge. And we need innovation to jumpstart the advanced nuclear energy industry. One idea is small modular reactors that standardizes design and can provide greater flexibility while also lowering capital costs. And also many advanced non-light water technologies provide superior performance, such as operating at higher temperatures, that enable them to provide energy services beyond just electricity generation, such as process heat for industrial processes. So our recommendations, again, this is just a quick summary, but they fall into these 3 categories. The first is reorienting and prioritizing research at the Department of Energy on advanced and small modular reactors. And then the second set is aimed at unlocking private sector innovation. This is a map from Third Way that identified 60 small businesses and universities that are conducting research in advanced nuclear energy concepts, including some in fusion. And here, things like the Versatile Test Reactor, which is a user facility that would enable testing of materials and fuels in a reactor environment, could enable more private sector innovation. Also, many technologies require high assay, low enriched uranium and need a domestic supply for testing. We also recommend expanding research into non-electricity applications, like I said, industrial process heat, hydrogen production, water desalination. For long-duration storage, this is a solution to managing variability of output from variable renewable electricity such as wind and solar over all time scales, from hourly to seasonal. I'm not going to dig into this because David Hart's talk is going to go into more detail, and he has a more detailed set of recommendations. Then a technology mission for carbon neutral fuels. Again, what we need is fuels that are as energy dense and cheap as petroleum-based fuels. And our recommendations here fall into two sets of categories. The first is to expand research into low carbon production of carbon neutral fuels, including hydrogen, ammonia, and synthetic hydrocarbons. And then also expanding research into applications of carbon neutral fuels beyond just use in transportation. So the harder to decarbonize transportation sectors, aviation, shipping, and long distance road transport, but also industrial process heat and electricity storage. And I should mention that the U.S. already has a program, has already invested a lot in hydrogen, mostly for use in fuel cell electric vehicles. So this basically expands that to other fuels and to other applications. Then a technology mission for carbon capture, utilization, and storage. CCUS technologies offer the only way to capture emissions from industrial processes, but they can also be coupled with fossil fuel energy, with coal-fired power plants and natural gas plants, to capture emissions from these cheap energy sources and enable their continued use in a low-carbon world. So here, Congress already passed the 45Q tax credit earlier this year, which provides an incentive of $50 per metric ton of storage. That's not going to be sufficient to incentivize greater deployment in many of these industries. For example, pulverized coal power plant cost estimates range from 60 to 120. So we need greater research and development to leverage the 45Q tax credit and bring these costs down. Now again, here DOE already has a program in carbon capture. It is entirely within the coal program's office. So we'd recommend expanding that to other sectors, including natural gas and including other industrial sectors. Also, while the capture technology itself is going to be fairly similar across sources, integrating carbon capture with each unique source will require optimization, will require demonstration, and will be unique to those sources. So that can only be addressed through demonstration. So we do recommend greater demonstration of CCUS technologies. And then greater R&D in carbon utilization and storage. Carbon utilization can turn carbon dioxide from a waste product into a product with value, increasing the market for carbon dioxide and potentially incentivizing greater deployment. For carbon dioxide removal, this will require brand new programs across a range of federal agencies. And again, this addresses the risk that any one of these technologies fails to materialize and the risk that we are not able to reduce emissions quickly enough. We recommend prioritizing pilot-scale demonstrations of direct air capture and mineral carbonation. These two approaches in particular have great potential capacity for carbon dioxide removal. They also have lower potential environmental impacts. And they're also in earlier stages than other carbon removal approaches. So we need to get started right away on direct air capture and mineral carbonation. And we also need interagency coordination because this draws on expertise from multiple agencies, from the U.S. Department of Agriculture, Department of Interior, U.S. Geologic Survey, and the Department of Energy and National Science Foundation. And the last one, we need more basic use-inspired research that supports clean energy. The federal government is great at supporting curiosity-driven research through NSF, through the national labs, and we also do a lot of work in applied energy, but less work up in this what's called past year's quadrant of use-inspired basic research. So we have a number of recommendations in this area, including, for example, doubling the number of energy frontier research centers within the DOE Office of Basic Energy Sciences and orienting them around these harder to decarbonize missions. For example, there are 46 EFRCs right now. Only one of them focuses on nuclear energy. We also recommend expanding National Science Foundation funding for the science underpinning clean technology breakthroughs. And we recommend full funding for the next generation of user facilities. These are large facilities like X-ray sources and neutron scanning facilities that are beyond the capabilities of any single university or private research lab to create. So these are going to be important for enabling private sector and public sector research. So just to conclude, I'm going to bring it back to this graph. We need innovation to address these hard to decarbonize sectors. We need to do more of what we're already doing, but we need new programs to do this harder to decarbonize set of sectors. And I'll conclude there, and we'll move on to long duration storage.
Thank you, Colin. I just really want to encourage people to look at the report. Colin just scratched the surface. This is a monster of a report. He has poured himself into this over several months. It's got an incredible amount of detail, and I really want to take the opportunity to publicly appreciate his work. This is sort of his coming out party here at ITIF. So thank you, Colin. I also want to thank Rob for his support of our program over the last year. I'm really happy to have him here today to join the discussion. And last, just mention the Spitzer Trust, which has been the funder of the project and has given me a chance to take a year off from George Mason, which I'm grateful for, as well as support Colin's work. Okay, so my paper is a deep dive into one of the gaps that Colin mentioned. So the big red slice here, what he labeled highly reliable electricity. There are a lot of different ways to fill this gap. This is what we today call baseload. But across much of the world, including in the U.S., we seem to be targeting just one path, and that's a path that relies very heavily on variable renewables like wind and solar. We're not building more hydro. We're not building much nuclear. We've barely scratched the surface on carbon capture. That doesn't mean we couldn't, and it certainly doesn't mean we shouldn't. So I endorse the agenda that Colin has put forward. We're going to need a robust portfolio of options to deal with this harder to decarbonize issue. But at the moment, because of the heavy emphasis on renewables, storage is, to me, the most glaring gap in our portfolio. I think everybody knows why. Storage is crucial. It's the variability of wind and solar, not just minute to minute or even day to day, but seasonal. And you need to back it up with something that can provide electricity, keep the lights on. People depend on electricity for lots of things. Obviously, all of us do, but so do hospitals, so do first responders, and so on. So it's got to be there when we flip the switch. Now, we actually have an old technology that does this pretty well, and that's called pump hydro storage. Basically, you have two reservoirs, one uphill from the other, and when you want to store power, you pump the water uphill, and then when you want to release the power, you let it go through turbines, just like any other dam. So it's pretty efficient, it's pretty big, and it's pretty long duration. And as this graph here shows, there's way more of this on the grid right now than there are any other kind of storage. So you can see more than 20 gigawatts of pumped hydro storage. This is just in the U.S., but the global figures are similar. All of our storage is dominated by pumped hydro. But then you can see over here, basically we've stopped building this in the last 20 to 30 years. So most of our pumped hydro, technology goes back to the 20s and 30s, but it came on the grid in a large way in the 70s and 80s. But partly because the best sites are taken, right? You need to have a place for two reservoirs that are reasonably close to each other and in relation to one another in elevation. But partly because of local environmental concerns, right? Damming up of valleys and so on. We're not building much hydro at all, and we're not building much pumped hydro. And I think this creates a dilemma for environmentalists, much way nuclear power does as well. We have to make some kind of a trade-off between local and global concerns. So I don't think we should forget about pumped hydro as we think about all the other technologies that could tackle this long duration problem. The other technologies that are currently in use on the grid for grid-connected storage, these are a bunch of different kinds, but you can see here that lithium-ion batteries have really just taken over the market in the last few years. So This scale, if you can't see it, goes from 2011 to 2016. It's even more so in 2017. These are global data, but the U.S. data are the same. The number I have for 2017 for the U.S. is that lithium-ion batteries have about 99% market share for grid-connected storage in the U.S. So lithium-ion batteries have really taken over this market, and in some ways created it, because the market has grown even as lithium-ion batteries have become dominant in it. With a couple of colleagues, we wrote a paper on this that was published by MIT Energy Initiative in April, and it looks at the kind of tension between short-duration technologies and long-duration technologies, and I'm not going to go into that here. I just wanted to reference that and encourage people to look at that if they're interested in the question of what we call technological lock-in, that lithium-ion batteries might squeeze out other kinds of technologies that could solve this problem. But here we're going to focus on the upside and the opportunities. So the key issue for lithium-ion batteries is whether they can get cheap enough for long-duration applications and meet what people are calling the baseload challenge. So that term baseload is still kicking around. There are various versions of this baseload challenge. How cheap does it have to be for how long? These numbers are taken from an ARPA-E workshop that was held last year before they started their program in this area. So we need storage that can last for, let's say, a week and cost as little as $20 per kilowatt hour or something in that range. Actually, I think it should be megawatt hour. $20 per kilowatt hour in terms of capital cost. One clue that we're not going to be there is that if we look at BNEF's new energy outlook, so BNEF is a prominent forecaster, relatively optimistic on renewables and lithium-ion batteries. Even they predict that gas peakers are going to grow by a factor of 4 through 2050, and that suggests that there really isn't backup from other kinds of sources, particularly from lithium-ion batteries, to cover the variable renewable gaps. So why is this? There's a number of different reasons. A lot of it is cost. They're too expensive. They rely on materials like cobalt that are potentially in short supply. They are prone to safety problems, particularly fires, although I have to say the big installations that have gone in so far have seemed to have avoided this problem. And they just don't last long enough. Now, maybe these problems will be solved, right? Lithium-ion technology has really surprised us in the last few years, and I don't want to sell it short. But it would be a good idea to have a backup, because there is an expert consensus that this technology is simply not going to get the job done in terms of meeting the baseload challenge if we get to very high penetrations of renewables on the grid. So here are some options. I'm just going to list them now. The paper goes into more detail. Already mentioned pump storage. Flow batteries are another. This is a proposal to create a battery that could power a city the size of Berlin. Liquid metal batteries, a spin-off from MIT that has the potential to at least get to 10 or 12 hours of very low-cost storage. This is concentrating solar power, which is rather than PV cells where the cells convert sunlight into electricity. This is the one where you have all the mirrors that focus on this power tower and generate like a turbine. In this particular plant, which is in Nevada, concentrating solar power is integrated with storage, a molten salt storage system, so that can provide up to 10 hours of storage. So this plant exists, but it's very expensive, and it was also supported with federal funds. But there are next iterations of this that could potentially improve on the cost there. Compressed air energy storage. I was recently in China where they're they're putting together the plan for a 100 megawatt compressed air energy storage system, which would be the biggest of its type. And then hydrogen, which Colin mentioned. This is the so-called P to G to P system that is power to gas to power. So you would use low carbon power like renewables to turn electricity into hydrogen, and then ultimately you could use that hydrogen for lots of different things, including generating power again. So all these have potential, but none are there yet, with the exception of pumped hydro, which faces these societal barriers. And even pumped hydro, there are ideas for R&D, new innovations that would improve pumped hydro, like putting pumped hydro underground or even underwater. So R&D on pumped hydro is still valuable. So what should we do? This report has way too many recommendations, as many of my critics internally have pointed out, so I would just refer you to read them. But I'll just highlight a few, and I want to echo many of Colin's themes. We need to set aggressive goals for this technology. We need to invest in a diverse portfolio of technologies across the full range of the innovation process, from basic research through to demonstration. We need to have mechanisms that pull the most promising technologies through that innovation process, so they don't get stuck in the applied research stage or basic research stage. So we need to get all the way through to commercialization and early adoption before we declare victory. This is an opportunity for international collaboration. So the COP24 starts next week. There'll be a number of events around R&D and international collaboration, and I think this is a topic that's ripe for that. For pumped hydro, some of these at the bottom deal with that. Somewhat different agenda, simply because the technology exists, so we can make better use of the pumped hydro that's already on the grid. We can make it easier to build new pumped hydro facilities, but we also need to, as I mentioned, pursue R&D and new concepts that try to overcome the geographical limits of pumped hydro, which are intrinsic to the technology as it's developed now. So with that, I want to say thanks again to Colin and Rob and our other speakers who will follow me. I hope this will be the first of several papers that do these kind of deep dives into the items on our deep decarbonization innovation agenda. And I think Judy is going to go next, so thank you.
Hi, thanks so much for having me. I'm going to give my perspective on bridging low-carbon innovation gaps. This is a theme that I'm going to return to throughout this brief presentation, that greenhouse gas emissions and therefore reductions result from the interplay of technology innovation, market forces, human behavior, and public policy. And public policy happens at multiple levels, including international, federal, state, and local. This is a pie chart of where U.S. greenhouse gas emissions come from by sector. This was in 2016. Transportation and electricity were the two biggest. Transportation recently has pulled out slightly ahead of electricity, so that's now our biggest emitting sector, followed by electricity, industry, commercial and residential, and agriculture. Just as a note, if you did a pie chart like this for global emissions, it would look a little bit different. Transportation would be a bit smaller, industry would be a bit bigger, and agriculture would be a bit bigger. This is a summary chart of the U.S. mid-century strategy for deep decarbonization that came out in November 2016. There was a lot going on that month, so you might have missed it. The Obama administration put this together as part of our obligations under the Paris Agreement. This slide violates all rules of slides because it's really hard to see. So you have in front of you, or at least those of you who are physically here, have printouts in color so that you can follow along. I can't spend too much time on this slide because I have a very brief time, but I'm happy to talk about it more. And also, this whole report used to be on the White House website. It's no longer there, but you can find it on the United Nations website because we submitted it there. So I have the link for that where you can find it if you're interested.
There's also an Obama 44 archive of everything that came out of the Obama White House.
Oh, that's good to know as well. Well, that's good. Okay. So so it's not lost. So this is, the y-axis is net emissions in gigatons of carbon dioxide for the U.S., and this was in 2005, and it's a little bit more than 6.5 gigatons. And net emissions means we have our gross emissions, what we're putting up into the atmosphere, and then we have our sink, which in the United States is significant, where we pull CO2 out of the atmosphere basically into our soils and lands and forests and agriculture. And so we have to get here on net emissions down to here by 2050. Hopefully this is showing, yeah. And so that's about an 80% reduction. But the lift is actually heavier than that because in our reference case, we actually expect some growth. This is a relatively pessimistic scenario, but it's plausibly pessimistic. And so this shows what would happen in our reference case: carbon dioxide, methane, nitrous oxide, and the F gases. And then we also expect our land sink to weaken over the next few decades in the reference case. So we're at about 10 gigatons in net emissions, and we got to get down below 2. So it's more than an an 80% reduction. So what we did is we looked at this sort of interplay of technology, policy, markets, and human behavior to figure out what strategies we could do sector by sector, source by source, to look at how we might get from here to there. And we have 3 big categories of strategies: transforming the energy system, sequestering carbon, and reducing non-CO2 emissions. And then within each of those, we go into greater detail. So happy to talk about this more either after the fact or in Q&A. So this is a little bit deeper on the energy piece of the MCS Mid-Century Strategy Vision. This, This is 2005 emissions. That's the pie chart by sector, and this is 2050. As you can see, the total pie is much smaller. And by sector, we get deep reductions in electricity, in commercial buildings, in residential buildings, in industry, and in transportation. But as you can also see, in 2050, most of what's left is in transportation. So why is transportation kind of the hardest sector? One way to think about this is that there's a 4-legged stool that drives transportation fuel use and emissions. That's vehicles, fuels, vehicle miles traveled, and system operations. And in the United States, at least, low oil prices are the big challenge in transportation and trying to reduce fuel use and emissions, and particularly in the United States, where we're not as willing as some other countries to tax our oil. So therefore, most historical progress in the United States has been through vehicle efficiency standards, which are both effective and politically popular. Other legs have been more difficult. However, we may be on the cusp of 3 revolutions that could really be game changers, and that's vehicle electrification, mobility as a service, that's like Lyft and Uber, and automation. But we actually are not assured that these trends are actually going to make things better. So in particular, this is from some work that we did when I was at the Department of Energy. Vehicle automation, for example, could actually take emissions in either directions. We did some work that showed you could see anywhere from a 60% reduction to a tripling of light-duty vehicle energy use by 2050. And it has a lot of different factors in play. One, for example, is that there are a lot of people who can't drive but could be driven. There are a lot of people who would be more willing to be driven than they are to drive. So you could wind up with big increases in vehicle miles traveled. That could be offset if more people ride share. It could also matter less if the vehicles are clean. So you could have you clean and so you won't have emitting vehicles. So this is just an area of really, really deep uncertainty. And what's motivating automation is mobility and safety. It's not really about energy and environment, but it has huge implications for energy and environment, and it really could go either way. So we did not incorporate this into our mid-century strategy because we didn't even know the sign, and you don't see much about this in the deep decarbonization literature because it's so uncertain. So this really requires more attention, in my view. I wanted to just give one example of how this technology, innovation, public policy, market forces, and human behavior could interplay for one of these hard to decarbonize sectors that Colin referred to. Basically, if you think about the airline hub system, and I had always been thinking that was optimal, economically optimal, but it turns out it actually may not be optimal, at least in some senses. So we've had about a 70-year shift to larger and longer range aircraft for regional air travel, and we've also had a decline in regional air service. And door-to-door times are actually worse now than they were 50 years ago, and we've got 96% of our air traffic in 1% of airports. And so there's this company called Zunum Aero that I got to see a good presentation by them a couple of months ago, and they say that what's happening now for regional air travel is that people go from where they're not to where they don't want to go. And so they have this idea that instead of having these big planes that have to go to the hubs to pick up lots of passengers so that they are cost effective and they fill their seats, why not use small planes to go from small regional airports to other small regional airports, maybe 10 to 12 passenger planes or 20 passenger planes. And if you do that, you actually could use batteries, they think. So this idea that we can't use batteries for air travel is probably correct, at least for quite some time, for the very big planes going very long distances. But they think that for the small planes going small distances, you actually could use batteries, and you would make people's travel times much shorter, and people value their time. So it's an interesting innovation that combines a business model innovation with technology innovation, and this is possible in many of these hard to decarbonize sectors. So I just wanted to remind people that 2050 is 32 years away. You might want to check your calendars. And That's pretty similar to the approximate lifetime ranges for various capital stocks. So building appliances we last about 10 to 20 years, cars 15 to 20, industrial equipment 10 to 30, power plants 40 to 60, buildings 50 to hundreds of years, and urban form hundreds of years. So we're making investments now in stuff that's going to still be around decades from now. So if we really want deep decarbonization, we have to start changing these decisions now so we have things in place that are lower emitting in these relevant time scales. So 2050 is not that far away. So the key takeaways, hopefully, from this are that bridging low carbon innovation gaps is a challenge, but it's doable. I hope that our U.S. mid-century strategy proved that or demonstrated that. Transportation needs more attention. Time is of the essence. We have to innovate faster. There are no facts about the future. Our emissions are up to us. Our emissions depend on how we, both individually and collectively, what we do in terms of policy, markets, innovation, and behavior, and that will determine the emissions that we have. That's all I got.
And we'll take a quick minute as we raise the slides and just take a minute, and then we'll get to Bob.
Go for it.
Yeah.
Are you okay?
Yep.
Well, thank you. Thank you, ITIF, for inviting me to come to this presentation today. Just quickly, C2ES is a nonprofit organization, nonpartisan and independent, and some people would classify us in that world as a think tank. We spent a lot of time working with the business community, and so I'm going to try to add a little bit of what is business doing in the near term as we talk about all these issues. Almost every one of the presentations before me, you could see the business engagement component to it, and I'm going to talk a little bit about why that is happening and what could make it maybe go faster and why it's necessary, and some examples. Right now, I think we can all agree that there's no coherent federal policy in the United States about climate change and greenhouse gases yet. Our greenhouse gas emissions have declined in the country since 2005, and there are many reasons for that. Virtually all of them have been touched on already, but a large part of that reason is in the electric sector and the retirement of coal plants, as you've heard, and the emergence of cost-effective renewables and more reliable natural gas supplies. And that's going to continue for a while. And but on the other side of the coin, we already heard from Judy that transportation in the United States now has surpassed all other sources of emissions. And it is, we used to have at EPA, and we have this also at C2ES, on all these issues, we have this term, it's complicated. It's a very high-tech term. But I think Judy explained what the variability could be in transportation emissions depending on a bunch of assumptions of what happens. I mean, it's quite remarkable. But why are businesses focused on this? And I think it's important to just put a little bit of context on this. If there's no coherent federal policy, why are some of these things happening? Well, we know in the power sector, which is reducing its emissions by almost 30% already since 2005, it's probably around 27. That is what's bringing, but the overall economy has gone down about 13%. So you can see that there are other countervailing forces going up, like transportation and industrial sources, or staying flat, and the power sector is going down. And since it's a third maybe of the the emissions, that's not enough to drag the whole thing down at that same level. But across the board, businesses are starting to focus on this much, much more, on greenhouse gases and perhaps under a broader term of sustainability. And some of the reasons are pretty straightforward business reasons. First of all, investors are starting to think about this. I have this term that I use when my title here is near-term opportunities. And one of the things that businesses are often forced into is what I call a near-term bubble. Whether it's the news cycle, like we heard with GM in the last couple of days, and how that affected their stock market their stock prices the next day, and what their focus is on their quarterly earnings reports. That whole thing I call the near-term bubble, which many people who reside in the C-suite of large corporations are focused on significantly, just because the financial implications are all tied to near-term performance. What's starting to creep in more and more is a long-term view. So my discussion here about near-term opportunities in the business world are actually related to the fact that more businesses are thinking long-term. I know that sounds like maybe a paradox, but they're taking actions now that are not only for the near term, they're taking actions now that are for the long term. And so these forces are at play. So you have big investors, like for instance BlackRock, and the CEO of BlackRock puts out an annual letter to all, and they manage $6 trillion. So it's not a small, financial institution. And Larry Fink is the CEO, and he put out a letter this year which implored all the people all the companies and other entities that they're involved with to start thinking about these long-term implications. And he actually decries the short-term, mentality. And so you have, if you're in business and your investors are now saying you need to take into account some of these long-term risks, all of a sudden you have a little bit of a dynamic, a little bit of an opening to start thinking long-term. You have customers, in many sectors, like these things. People who buy these, they expect it's being made somehow in a sustainable way. Don't look inside. However, people like companies like Apple, have goals, and they've achieved, maybe not on a 24/7, 365 day, but on an annual average, they cover all their data centers, for instance, with renewable energy. So you got customers, you got employees. The workforce is getting younger and younger. This is just a reality of demographics, and younger employees are more interested in these sustainability issues. They want to work for a company that is responsible. So you have entities like, and this is drifting off subject here a little bit, but you have entities like the Bank of America saying they're not going to invest in companies that make assault weapons to be sold to civilians. This is an unheard of kind of thinking that's starting to come into corporate policy. And so you also have recruitment. If you want to recruit the best and brightest of the young crop of MBAs, for instance, or engineers, most of them are interested in going into a job where they can actually make a difference. And so competition for the talent is pretty stiff. So, and then you have boards, and then you're starting to have the chief financial officers saying, well, what's the long-term risk here of our facilities? What's the long-term risk of we don't do anything now because we don't have to, and then all of a sudden we have to reduce our carbon emissions, right away on some new regulation. And so companies are sort of, there's no, I don't want to make it sound like there's a unified, march here, but because you certainly have many companies that are not doing things, and you have some of the trade associations who seem to be working in counterintuitive ways, but a substantial number of large corporations, Fortune 500 companies, are now in very serious processes of thinking about how they reduce their greenhouse gases, what their role is going to be in a carbon-constrained world, regardless of whether the fact that there's no coherent federal policy. They expect that someday there'll be one, and in fact, if there was one, it would help accelerate some of these innovations we've been talking about. Well, let me just give a couple of quick examples here, and then we can open it up for questions. Because, so for instance, renewable energy, I think most of us have seen this in the news and recognize it, that many large, particularly technology company users of electricity have made these large commitments to get renewable energy. This is creating, in addition to tax credits, this is creating demand for renewable energy, as are state programs that are having renewable energy portfolios. And then you have the power industry itself, who is starting to move toward making these investments. And the reason that this is important is because in order to mobilize technology or to learn how to get better at it, and we saw some thoughts already about how second and third generations of some of these technologies we can keep reducing the cost, we need the mobilization of large amounts of capital that can only be done by the private sector. And so we see, even in the power industry, for instance, PSEG, which is the electric provider in New Jersey, just announced a $2.8 billion 5-year plan to do energy efficiency, electric vehicle infrastructure, and renewable energy. DTE is the power company that supplies electricity for the southern part of Michigan, automobile world, or used to be. They have a goal that's already been approved by the Public Service Commission in Michigan to reduce their greenhouse gases by 2040, I think it's 2045, by 80%. And this was a coal-dependent utility. So you have many of these examples. In the carbon capture arena, there's a coalition of businesses that's called the Carbon Capture Coalition, who worked with Congress to get the tax incentives for the 45Q tax incentive for more carbon capture. But also important is the use of the carbon. If we start capturing a lot of carbon from industrial and other sources, we're going to have to use it. The intersection of nuclear and heat for industry, which has already been mentioned. And in the transportation arena, I'll wrap up on that and say that even though it's complicated, there is a international agreement now under the International Civil Aviation Organization to get the global aviation industry to be carbon neutral. It is the only global sector that actually has this adopted goal. That's going to require offsets in the near term, but that's something that's unfolding between now and the mid-2020s. And so you have a lot of different technologies that the automobile and transportation industry is investing in, whether it's hydrogen fuel cell, electricity sources for electric motors, to battery electric vehicles. A lot of research and a lot of development has been done on these vehicles. Their cost is still not where it needs to be, but that's not because of the engine, or the motor, I should say. It's because of the source of electricity, whether it's a battery or a fuel cell, and getting those costs down. So there's lots of investment going on in the private sector, lots of forces at play in the private sector for near-term action, because ironically and paradoxically, the industry is starting to think also long-term. And so I'll stop there.
Great. All right. Thank you, Bob. So why don't we open it up for questions? We've got 30 minutes. We're going to end right at 11:30, if not a few minutes before. So if you have a question or comment, if you can go over here to Vinny, if you can wait until you get the microphone, identify who you are and who you're with, and then if there's a question to a particular person.
Thank you. Hi, Vincent Catalano, Red Mount Capital Partners. Question for David and maybe Colin. How close do you think Judy's regional jet battery, how close are we to that? Because that is very intriguing. And then for Bob, I do have a comment and a question. The comment is, since I come from Wall Street, I do agree with the spirit of everything that you said, but disagree with the conclusions because of the motivations of short-termism and things of that sort. However, private equity kind of fits right into that, because their time horizon is different. I'd like to know if you have any thoughts on that. So first, the battery plane, and then the other one is private equity with long-term horizons. Thanks.
Yeah, I'm not sure why that's on me, but I'll let Judy take a crack at it. No, all I know about it is what I heard on Green Tech Media's podcast. So, and that was like the entrepreneur giving his sell that that these things could transform the aviation industry. I think lithium-ion batteries, and I assume that's going to be the technology there. They're getting cheaper, but the question of getting denser, I think, is probably the bigger challenge for something like that. But I don't, I'm not close enough to say. So I don't know whether you want to give an assessment of that.
Yeah, I actually didn't mean to either tout or dismiss the technology. I just wanted to give it as an example of it's about the technology, but it's also about other things. Because the reason that might work, if the technology works, is because they're rethinking the whole way we do air travel. So it's sort of stepping back and thinking about how we get around by air, and maybe you rethink the whole thing, and so different technology options become more feasible in different circumstances. But yeah, the same thing. I've seen their presentation. They're very excited about it. I think they're optimistic. But whether that actually pans out, I don't have an independent assessment, but it's certainly interesting, and it's an interesting way to think about this whole space. That analogously, like, think about how the whole power system is evolving, where it might actually be feasible now to have smaller power systems than it was originally when we used to think bigger. Similarly, the whole way mobility is changing for Uber and Lyft weren't really thought of a while ago. So just these whole ways we do our business and move around can change, and that opens up different opportunities for technology innovation.
I would also say, Vinny, if you're interested, you can come back on Monday at 3 o'clock. We have an event here on, it is on advancing the next wave of aviation innovation. So it's looking at a whole set of different kind of more transformative or breakthrough ways of innovation, and we'll have somebody from NASA as well as a presenter, so maybe we'll answer that question on Monday. Bob?
Well, first of all, I'll say I agree. We're not there on long-term thinking in corporate America. There's no doubt about it. I would guess that I call it the short-term bubble. They're driven by the news and also by the quarterly earnings statements, and it even gets more arcane, as you probably know better than I. Between what analyst is saying what and whether somebody gets it or not, and I mean, it would drive me nuts. But I think that there's what I said is that I think that there's been a crack in the bubble. I think that there's been a little bit of a crack in the bubble because some investors are starting to think a little bit more long term, and it's giving some space for some companies that have probably the liquidity to do it to think a little bit more about it. So not a panacea yet, but it's a pressure that's there, particularly for larger companies, to start having some of that long-term thinking. There's also the financial disclosure issue, risk disclosure issues that are starting to creep into the corporate reporting requirements of the Securities Exchange Commission and others that require them to at least have to start thinking about, do they have some long-term financial or physical risk from climate change? So cracks in the bubble. And that's why I think we probably will agree that there's some cracks, and how much it's influencing, I don't know enough to be better than what I've already said. And so in terms of your other question was on private equity, or what?
Private equity lends itself towards
Right.
that crack.
Right.
In other words, the time horizon is longer.
Yeah.
And then you have institutional money like CalPERS and others.
Yeah.
Putting more and more of their money into private equity.
Right.
And so with that,
Right. And they have an ability to think a little bit more long term, and I think the Larry Finks of the world are also in that kind of thinking a little bit longer term. So I think that those combined forces have created a crack, and that's not, the C-suites are not ignoring that crack. They know it's happened.
Other questions?
Can I just make one point about that? One of the things that matters a lot is the fact that we have a global economy And so even if you have a lack of public policy in one jurisdiction, if you have public policy in another jurisdiction and you've got a company that operates in multiple jurisdictions, they have some incentive to think about everything they do so that they can operate in the jurisdictions where there is policy. So I do think there is some incentive even when, one, for example, really large emitting nation isn't doing much. Because other large emitting nations are taking action, those companies that operate there have some incentive to think about how they'd comply.
Hello, I'm Mario Ordaneta. I'm between positions. I'm representing myself today. Could you please comment on which of your recommendations are in line with the priorities of the current administration and therefore ripe for immediate action?
Sure. So I think we've already seen a lot of movement, at least in Congress, both in carbon capture, utilization, and storage, and in advanced nuclear energy. In fact, a lot of the recommendations that we have for advanced nuclear energy are incorporated in the Nuclear Energy Leadership Act, which is a bipartisan act in the Senate that's coming up for a hearing on Thursday. Of course, the challenge there is not just passing the act, but then funding at a level that is commensurate with the challenge. But I think we've seen a lot of movement in advanced nuclear. I think for carbon capture also with the 45Q tax credit, that will hopefully incentivize greater carbon capture, and not just in the power sector. That can really help for ethanol production and for natural gas processing and some of these other facilities that are really low-hanging fruit where the waste stream is very high concentration, high purity CO2. So there has been movement in Congress. The administration doesn't really seem to have any priorities in this area. So I think if Congress does something, they'll go along with it.
Okay. Other comments or questions? Okay.
Hi, I'm Beth Zittler from the National Academies. Colin, thank you so much for the report. We're really digging through it and glad for it. My question is about, the report obviously covers a number of different areas that are high priority and kind of gaps in the current research portfolio. And what I'm curious about, and it relates a little bit to Mario's question maybe, is what do you see as some of the barriers to getting that portfolio implemented? And maybe an easier version of that question that is kind of what do you think is some of the places where the government could really spur the needed innovation, like some of the earliest steps? Obviously the report goes through a number of your big portfolio, but what are some that you'd like to highlight?
So Beth was a program officer on the recent National Academy study on carbon dioxide utilization. So I'm sure you can answer some of that a lot better than I can, at least the technical side. Thanks. So I think for carbon utilization, I'll talk there. The DOE Office of Fossil Energy already has a small program in carbon dioxide utilization. It needs to be expanded. I think the fact that it exists provides an easier vehicle for appropriators to come back next year and say we want to fund this at a larger level. In fact, they've already done that. They bumped up funding, I believe, from $12 million in 2018 to $20 million in 2019. That's not going to be enough to pursue all of the options in the National Academy's report. But areas like that where appropriators can do something without additional authorizing authority are, in some cases, a little bit easier. We still have the budget caps, which is we're gonna see how that plays out in the next session. And then again, to Mario's question, I do think there's newer focus on carbon dioxide removal. It's the shiny new object that's capturing a lot of attention. And I think it's likely that at least some additional legislation will be introduced in the next session. We already have some. We've got the Fossil Energy R&D Act in the House and the Use It Act in the Senate. But these came out before the recent National Academy study on carbon dioxide removal. So I think that's going to be a big issue during the next session.
Can I comment on that as well? I just wanted to note that this year that we're in, the fiscal year 2018, the administration initial 2019, the administration initially proposed a big cut in DOE's budget, and then Congress not only restored DOE's budget to what it was last year, but they actually got a big increase or significant increase in these budgetary times. I think DOE's budget overall is up like 13%. So there is actually an opportunity there seems to be great interest, at least in Congress, in the innovation agenda that includes many of the things that Colin mentioned in his report. So I think there is reason, I mean, you never know how these things are going to play out, but there is reason to believe that we have a good chance with Congress to actually continue a very robust innovation agenda.
I would look at it as there's really two issues involved in this. One is about sort of the overall level of the lake, if you will. You know, is there just interest in supporting an innovation agenda to solve climate? And then the second is, if there's that, how do you allocate that? And how do you make sure that these gaps that Colin's report and then David's report identify, how do you make sure that they get the right attention, both sort of in institutional reform and fiscal resources? The first problem is frankly the most important problem, because the lion's share of the climate activists and organizations in the U.S. at best give short shrift to innovation, at best. So if you go and look at that big conference out in San Francisco, where I think every climate activist and his brother and sister were there, it was probably in September, I think, there were no sessions on innovation. I mean, really, there were no sessions on innovation. It was all about, you know, could we make the fuel, you know, put the fuel economy efficiency of cars up, which is a meaningless thing. It has no effect on anything because the rest of the world is buying cars much faster than we can make our cars more efficient. So I think at the end of the day, one of the things that has to happen for this to really go forward is the environmental community, the climate change community, the activists, they're going to have to understand that innovation has to be part of their agenda. I'm not going to say it be everything, I get that, but you know, the people who are involved in the innovation clean energy agenda, not counting the people in government who are doing the yeoman's work of actually making this happen, but the people who are involved in the sort of the policy world of this is quite small. It's quite small. And it's a wholesale process. It's not a retail process. It's, you know, somebody on the Hill reading Colin's report, or somebody reading Third Way's report, or somebody reading Bipartisan Policy Center's report. So I just think that's got to happen for this to ever really budge, and particularly at the level, the scale we need and the speed we need. I mean, we got to do this big in 5 years. And unless the environmental community sort of comes to the table and says that, I think it's going to be hard, particularly with the Democrats in power in the House. You know, the question is, what agenda are the Democrats going to follow when it comes to climate? Is it going to be a let's stop an oil pipeline, which, you know, has absolutely zero effect on climate? And yet, there are people on the climate left who want to put all, you know, Bill McKibben, put all their efforts into stopping an oil pipeline when we should be putting all our efforts into, you know, tripling ARPA-E. So that's my soapbox. Sorry, I had to say it. I say that every 6 months, and now I'm good till the spring of 2019.
Can I just comment on one thing? I agree with most of your soapbox that we really do need to focus more on innovation, and it's a problem that we're not focusing enough on it. However, I disagree strongly about fuel efficiency standards. I think fuel efficiency standards are super important, and they interact with innovation, and they're the best tool we've got. They're not ideal, but they're the best tool we've got, and I think strengthening them is super important.
Well, Judy, my point would be, it really is completely irrelevant whether you have internal combustion engines that get 23 miles a gallon or 35 miles a gallon. Completely irrelevant, because they're just going to be, the growth of internal combustion vehicles in the world is going to be massive, and it'll outweigh anything we do. Now, your point I take is a good point, that if you design fuel economy efficiency standards right, you can provide incentives for switching to non-internal combustion fuels. Sure, but just the idea that if we just got more fuel efficient cars, that has any meaning That's where I would disagree. I just don't see that as, it's sort of like saying there's a giant tide coming towards us, and I'm going to take a bucket and I'm going to get rid of a few buckets of water.
I'll add more comments to Judy's, Rob, just to keep fun on this, because first of all, what EPA did was not fuel economy standards. It was a performance standard of greenhouse gases per mile driven, and you can drive that to zero with the authorities under the Clean Air Act. You could drive it down to zero, and that would force people to have an internal combustion engine that doesn't emit carbon or some other kind of propulsion. And so, and if the United States can innovate on those technologies, then they can be exported to other countries. So you may have a flood coming, but until you start diverting some of the water, you're not going to get anywhere. So you can't throw up your hands and be frustrated about it. You have to push the technology. And what declining grams per mile of greenhouse gases out of a tailpipe over time does, it forces the industry to innovate and create different kinds of drive systems for personal transportation.
See, I know what you're saying, but I think, first of all, it's not going to be GM or Toyota that are going to innovate in batteries. And that's not their business, and that's all that matters. It's all that matters. So, clearly Ford and Toyota and GM are innovating in electrification of the vehicle and control systems. All good, all great. But until you innovate in batteries, it's just not going to happen. The facts, for example, everybody touts a carbon tax, which we support. Just put that out there. But you look at Europe, they have the highest carbon tax in the world on gasoline. It's about $400 a ton. It's called their gas tax. And they have fewer electric vehicles than we do. And why? It's because it's not a demand problem. It's not a push. It's a supply push problem.
They have the cars now, and nobody's buying them. So
right.
The issue is forcing it by reducing.
See, I don't buy that, because first of all, we have an administration that doesn't like that. Secondly, let's just look at what France is doing. You can only force people so far before they rebel and say, I'm not. It's like people with low flush toilets. It's like, I'm not going to get one of those things. I don't. Yeah, sure, at the margin this helps, but my point is, we did a report 3 or 4 years ago in our clean energy work, and we looked at basically a set of about 15 technology breakthroughs in the last 200 years since the rise of the Industrial Revolution. Sort of really important breakthroughs, not incremental advancements, but breakthroughs. None of them had to do with changes in demand, changes in price, none of them. They all had to do with fundamental technology breakthroughs. And that's, I guess, the point that when I look at Colin's report and David's report, that's really the point we're making, is you can't ignore fundamental technology breakthroughs. The idea that we can sort of wish it and hope it and, can push it a little bit. Sure, we can do all that, and we should do all that. But there are a lot of people out there who have it in their mind that if we do that, there's an op-ed the other day, if we do that, we're good to go. And I just... or the second version is we're good to go because that alone will induce the innovation we need. And I know you're not saying that, or Judy, but there are a lot of people out there who do say that. And I think that's just, that's, as David put in his paper, what was your paper?
Magical thinking.
Magical thinking. That's just sort of magical thinking.
Yeah, I think when I talk about carbon taxes, I always say there's not enough magic in the market to make something happen by just raising the price of stuff. There's the other counterpoint that we've all discussed already here are incentives that have been created that creates maybe an incentive for somebody to try to innovate, like these tax credits and things. That's going in the other direction. It's actually spending money, right, because it's reducing federal taxes. But yes, the solution to all this, we've drifted into this larger conversation here, but the solution to all this is as complicated as any of the particular technologies are. And I think the biggest thing that the climate advocacy community needs to do, and I think these most recent science reports may help provide some push on the urgency here, is that we need every egg in the basket, so to speak, if you use the old. We need all these different technology developments to be nurtured and aided along by a lot of different kinds of policy incentives and other other approaches, including investment in research and the stimulation of research by the private sector and the mobilization of private capital to get these things penetrated and deployed. But it's not, there's no single answer to this, and there's no single technology or approach. And so I think that's the key here. Innovation is a key component of that, but the main thing is innovate on a whole host of different technologies, of which Colin's report identifies those gaps clearly as
I absolutely, but my point is more, a lot of environmental or climate organizations will say that, but they don't really put the shoulder to the wheel behind it. They don't lobby on it, they don't score votes on it, they don't push on it. They'll say it, yeah, we need everything, sure, innovation's good. But at the end of the day, it's not about we need everything, it's about what are the priorities and what are you willing to fight for. And my point is I see too many climate organizations who might say it, but at the end of the day, they don't lift a finger to really make it happen. I mean, when you think about the RPE budget, which we organized something, or somebody organized something that we were part of, there should have been a lot more environmental organizations on that. And there weren't. There were some, but there weren't enough.
Well, and to that point, I think it was a really good sign that in FY 2018, when the Trump budget proposed slashing the Department of Energy by a vast amount, by 80%, I think, for EERE, for FE, for nuclear energy. A lot of the innovation-minded think tanks and some more sciencey-minded climate think tanks really banded together to support the Department of Energy, to work with Congress to reject that budget and to actually increase funding levels. So I hope that we are building more of a consensus around the need for energy innovation as a tool to address climate change.
So any other questions, comments? In the back there, sir?
Hi, Adam Rosenberg with the House Science Committee. Okay, so you all have a consensus that we need a lot more support, investment in energy innovation, and regulation or tax policy might not cut it. Do you have an estimate of the scale of investment that you would need, and any recommendations on mechanisms to ensure that level of investment over the next 10 years?
We don't have top-line numbers, at least that's not in this report, although ITAF has called for increasing the budget for RP to $1 billion and doubling National Science Foundation funding. There are some targeted recommendations that are more tied to specific numbers, for example, for the versatile test reactor. Right now, the Department of Energy, as I understand it, is scoping out what that would be and what that would cost, and I don't think that there are cost estimates yet. So after this initial study and scoping period, I think we go with that number. I think for the National Academy's study on carbon dioxide removal, they actually came out with a very detailed R&D agenda with line item numbers for those numbers for each program. I think but for the other numbers, I don't have a number for you, but a lot.
So we did a report, Adam, I can send these to you. This is probably 3 or 4 years ago where we did that in a report on sort of how much should we be spending or investing. And I don't remember the number offhand, but it was at least double. So I can send you that. And then we also identified a number of pay-fors, which I'm not saying are easy pay-fors, but they are pay-fors. One was a carbon tax where you could allocate, say, 10% of the revenues to a clean energy fund or, towards clean energy R&D. A second was a sort of grand bargain, which actually I talked to Stephen Moore once from Heritage, and we were on a panel together, and he thought it was a great grand bargain, so maybe it's something Republicans would go along with, because Steve's a conservative, which was to allow and increase more drilling on federal lands, including offshore, but to do that increase the royalty fees and take 100% of those royalty fees and give them to clean energy R&D, maybe ARPA-E or other places like that. And then obviously another one was, which is certainly hard, I get it, but reduce some of the oil and gas subsidies we have and move those over, which is revenue neutral but politically difficult. Sure.
Yeah, I would just add that I think the Mission Innovation Agreement among it's like 20 or so countries around the world to roughly double federal investment in clean energy R&D is roughly right. The group of countries agreed to double their investment over a 5-year period. And when I was at the Department of Energy, we worked through what that would look like program by program. So I think in terms of the rough scale, I think that's about right. And somewhat oddly, we're not that far off track of that, because even though the administration proposed to cut DOE's budget, Congress actually increased it. So we're actually, we're not quite on the trajectory, which would require like a 20% increase per year, but I think we got a 13%, so it's not that bad.
I also just want to mention, in addition to looking at the cost of R&D, it's also important to consider the benefits. So I showed you projections of emissions under a doubling of R&D scenario. One thing that I didn't show you, and this is, well, you can check my report, there's a citation in there, is that the impact on residential energy bills declined under this aggressive R&D scenario. So, and in fact, if you coupled that aggressive R&D scenario with a carbon tax, energy bills still declined, because R&D, by lowering the cost of clean energy technologies, can make regulations cheaper. So I say that because my final response to your question was a lot. I think we do need to invest a lot more in R&D, but it's not just about the cost. It also has benefits beyond just emissions reductions.
Well, great. Thank you. So first of all, I want to thank the panelists here today, and particularly Colin. Great report, Colin. We look forward to many more next week.
Yes.
So thank you. And thank you all for joining us. And if you're interested, the video will be online. And hope you all have a good rest of the day. Thank you. Thank you.